All right, everybody, this is video number 6. This lesson has a lot of material for us to cover, and we are nearing the end, but it is possible that I will have to break example 4 into 2 videos because I really want to walk you through it well. So just have that expectation and know that the videos are going to take a little bit longer to watch on Monday than they have in the past. And let's get going on this. So the heading for example 4 is writing equations of bisectors in the coordinate plane. Here's our coordinate plane. Here is the original line segment, and here is the perpendicular bisector running through it. And what we are going to do is learn how to glean the information from this line segment that we need in order to write the equation of a line for this perpendicular bisector. So we're going to move over to my notebook, and we will be going back and forth between my notebook and that diagram. But there are a couple of things, or actually a few, that we need to review. So they ask for the line equation, or the equation of the line, for the bisector, the perpendicular bisector, to be in point slope form. It's been several weeks since we discussed this, so I think we need a quick review. There is one that you are probably more familiar with, and that is slope-intercept form, and that is y equals mx plus b. But when we were learning y equals mx plus b this year, we also learned point slope form right along with it, and that is y minus y1 equals m times x minus x1. And generally, to do this form of a line, we're only going to have one set of points. We're only going to have one x and one y. So you would plug your 1x in here and your 1y in there, and just to give you a good reminder, m is slope. So your slope goes right here in this equation, and it goes at the m in the slope-intercept form equation also. So there's our point slope form that we're ultimately going to need to solve the problem. Another thing that we're going to need is the midpoint formula. The midpoint formula helps us find the middle between two endpoints. So we are looking for this right here, but without using the graph. We want to use our mathematics to do it, our geometry formula. So we have m for midpoint in this case equals, give me just a second to look at something. Okay, m in this case equals the first x plus the second x divided by 2, and the first y and the second y divided by 2. The reason we have it in parentheses divided by a comma is because this is a coordinate pair. This is the x and the y that we are solving for, and it's going to take us to a specific location on the graph. Another thing that we need to review is our slope formula. Our slope formula is how we solve for m using two sets of points. So we say the second y minus the first y over the second x minus the first x. And the last thing we need to remember or review is that a perpendicular line's slope is always going to be the negative reciprocal of the line that it's perpendicular to. So let's say we had a line with a slope of 5/3. Well, if we want to draw a line perpendicular to that, then its slope is first of all going to have to be the opposite. So it's going to be negative, and then it's going to be 3/5 instead of 5/3. You can also call this the opposite reciprocal. In this case, negative really does mean opposite, so if it's already negative, then you're going to make it positive. All right, moving on. Let's get started on this problem. So here is the line segment that we want to bisect perpendicularly, and we are given the points for A and B. This A and this B, and I've written them in my notebook. So the points for A are -1 and 6. The points for B, or I'm sorry, the point for A is -1 and 6, and the point for B is 3 and 4. So the first thing we need to do is find the midpoint so that we know where that perpendicular line is going to pass through. It has to be in the middle. We need to do that mathematically using our midpoint formula. Our midpoint formula, I'm trying to get it so you can see. So we just reviewed it. Again, this is it, x1 plus x2 over 2 and y1 plus y2 over 2. So I plugged in our x1, which is right here. So I said -1 plus 3 over 2. And then I said 6 plus 4 over 2. And that was pretty easy. That came out to equal 1 and 5. Our x in the coordinate is 1 and our y in the coordinate is 5. And that's exactly what the diagram shows us right here. Okay, the next thing that I need to do, now remember, I'm going to need to come back to this information. That is why I have circled it. The next thing I need to do is to solve for the slope of this line right there. Because only then will I know what the slope of this perpendicular line needs to be. So I used my slope formula. M equals y2 minus y1 over x2 minus x1. And let's see, where did I do that? Here we go. I did it right here. So I plugged in y2 as 4, y1 as 6. Okay. And then here, 3, the x1, minus, and that was the x2. This is the x1. And our x1 is actually a negative 1. So it had to be 3 minus negative 1, which is going to become 3 plus 1. So we have 4 minus 6 is negative 2. 3 plus 1 is 4. So we're going to have our final slope as negative 1/2. All right, so that is the slope of this red line segment, negative 1/2. What does that tell us that the slope will then be for this perpendicular line? It has to be the opposite reciprocal. So it's no longer going to be negative, it's now going to be positive, and we've got to flip the 1/2 and make it 2/1. We don't need to keep it 2/1 though, we can simply make it 2. So the slope of the perpendicular bisector is simply 2. All right, I'm going to stop there and pick up on video number 7 to finish this off.